The OAuth specification, or the second version of it, OAuth 2.0, was really designed to solve a whole host of different authentication problems with web-based services. Now, there are a variety of different what are called flows within OAuth 2.0 that can be used to authenticate and control access to different web-based applications, like the ones that we're building in our cloud services. But we're going to focus on one specific flow that is most relevant if you're building your own application to access your own cloud service that you've created. And this type of flow doesn't make sense if the application that you're accessing is not your own. So if you are either accessing a cloud service that you didn't build, or it's somebody else's application accessing your cloud service, or your application accessing somebody else's cloud service, it doesn't make sense. This only makes sense when you are the creator of both the application and the cloud service. So this part of OAuth is called the Resource Owner Password Grant, or basically an approach for replacing the original username and password approach where we get a session token back, but with something that's more flexible and makes more sense from a mobile environment. So the idea behind this is that we have something that's called the authorization server. And then we have our resource server. And these are just using OAuth terms. What the resource server is it's really the controllers and stuff that you've been writing. This is really the logic behind your application that you're building. So the term resource server, it doesn't mean anything new. It's just all of the logic that you're trying to provide access to, the resources, the cloud service that you're trying to provide. The authorization server is the thing that's going to control access to resources. So it's the thing that's going to decide and manage who can access your controllers and the different methods in your controllers is the way to think of it. So with OAuth 2, the way this works with a password grant is a client comes along, and just like before, because this is our own client that we're building and not someone else's, and this is a really important point, it shows a login form. So this is going to be like on our mobile client. And then it sends a request to the authorization server for a password grant. And this is really just a fancy way of saying that it's trying to log in with your username and password. And what the authorization server does is it returns something that is similar to a session cookie, but it's called a token, and it's going to be a piece of data that you can then use. It's the equivalent of that valet key for the web. So when you go and you're parking your car and you want to give access to the valet to park your car, but you may not want to give them access to your trunk, you give them your valet key, which only gives them access to a subset of the capabilities of your car. Well, the tokens that an authorization server returns can be set up so that they only grant access to a certain set of resources. So the client then gets this token, which is long-lived, and when it wants to go and access a resource, it has to use the token to get past and get access to the resource that it wants. And so what happens is that the token is provided to essentially establish your identity, just like the original session cookie was used to establish your identity, except that this token has not only a user identity, but it also has the allowed resources that the client is allowed to get access to. So you could have different clients or different apps use this grant, although just to be clear here, if you are using the password grant, you should be the one that is writing the client application. But the idea is that you don't have to give up full access. You can log in essentially with the username and password and get a token back that provides access to an arbitrary subset of the resources on the server. The other thing that's important is that what the client is actually storing, which is the token, is not your username and password. So if for some reason your token is compromised or your client is compromised, you can just revoke that token without having to invoke your username and password. Similarly, you can set it up so that you can go and change your password without necessarily revoking all of the tokens. And you can control the timing and expiration of these tokens to make it the clients essentially have to log in again at the intervals that you want. So OAuth 2 looks similar to the typical login with your password and get a session cookie back, but it's more sophisticated. It provides token-based access that makes more sense for a mobile client. It also provides finer granularity over the control of your resources. And your resources are really the methods on your controllers. So defining which methods on your controllers can be accessed. And you can change that depending on the request and what the client is asking for. You can send it back a token that only gives it access to the resources or your controller methods that it needs access to. And then the client, each client can have its own token that it sends to the authorization server in order to gain access to some resource on your server. And again, these resources are just controllers. So you get a more fine-grained access. There are other flows in OAuth that allow other clients that aren't created by you to get access to tokens without having that app show a login screen that's controlled by that client. But those flows are not exactly relevant to us at the moment because we're going to be creating our own client and our own service and consuming our own service. But if you're interested in them, there are other flows that essentially allow these clients to go and ask for access, redirect the user to a web page that's controlled by this server where the user logs in and then accepts or denies access for this particular client. And you've probably seen these types of web pages when you're trying to access Google services or Facebook services potentially from a client that you are writing. Now, if you were going to implement all of this infrastructure for going and receiving tokens from the server and deciding which clients should and shouldn't get tokens and which clients were allowed to ask for tokens and which token represented access to which resources, it'd be a lot of work. But Spring has a built-in implementation of OAuth 2 and Spring Security. And so what we can do is we can simply configure the existing implementation that Spring Security provides rather than trying to build our own implementation of the complex OAuth 2 specification. And Spring Security's implementation provides implementations of all the flows, not just the password grant flow that we're talking about for our mobile client. But luckily for our password grant flow, Spring already provides an implementation of that flow. So what we have to do is, if we go back and look at the way this works, is we have our auth server or our authorization server, and then we have our resource server. And again, this is your controllers and the methods on them, which are the resources. So you have your controllers and methods of the resources that are the resource server. The auth server, this is a controller provided by Spring Security that knows how to provide tokens and check tokens on incoming requests. So this is basically going to have a separate endpoint for getting tokens that's going to, depending on how you configure it, be something like OAuth/token. And those requests will be piped into this controller from Spring Security. And then when you go and send a request, there will be a filter that's actually going and intercepting the request and checking for a token. So Spring Security is doing all of this token work for you. And then depending on what token is in there, it figures out what user is accessing it, so you can get access to information about the user. But the other thing is you can provide additional security information or annotations on your controllers, so you can basically provide security restrictions based on OAuth. So we can go and say, for example, that if the client is sending a request with a token, that token must have a particular scope applied to it. So scopes in OAuth terms are the sort of controls over the sets of resources that a client can access. So similar to we had users had roles when we were doing Spring Security before, which is simple session management. OAuth has the concept of a scope. So we can go and add assertions about the methods in our controllers, saying that if a client is accessing a particular controller method through OAuth, the token that they're providing must have a certain scope associated with it. So it's not just a user, but it's a particular scope that then defines the actual methods or controllers that client can get access to. And so you can take the same username and password and dish up different tokens that have different scopes attached to them, and then use the different tokens to either be able to or not be able to access a particular controller and method. So each time a client goes and asks for a token from the server is going to decide what scopes to put into that token. So the client will say, I would like a token that has these scopes. The server will decide if that's okay. If it is, it will create a token that specifically has the scopes that the client asked for. And then when the client sends a request, if its token has the scope that it needs to get access to that controller method, then the method will proceed. But if the token doesn't have the scope that the client needs to get access to that controller method, the request won't succeed, and the client will be told that it's authorization denied or something like that, access denied.